Hello everyone. So for number 12, we're again looking at a modeling question here, whether something is linear or whether it's some other type of function, perhaps exponential, quadratic, or any type of other special function here. But we're looking for a linear function. So let's just kind of differentiate here, explain the differences between the major functions that we know. So with the linear function, the main one we're kind of looking for, some properties that a linear function have. What do you know about a linear function? It should have a constant rate of change. That constant rate of change, I'm just going to abbreviate it ROC, is what we know as slope. So in other words, over an equal interval, it's going to have an equal difference. Something like as x increases by 1, y should be increasing by 3, something like that. There shouldn't be any type of extraordinary change between the same values. Constant rate of change. Now on the other hand, if we think about some other type of functions, let's just start with exponential. With exponential functions, we do not have a constant rate of change. Exponential functions, we know that J-shaped curve that we've seen earlier in this exam. But with an exponential function, again, not a constant rate of change, but instead we have some type of common multiple. In other words, something where we're doubling, tripling. It might be decay where we're decreasing, so it's like times 0.25 or times something like that, something less than 1. So common multiplier. In other words, the rate of change, again ROC here, is not constant. Okay, so with those in mind, let's take a look at these choices. A bank account balance that grows at 5% per year compounded annually. Right away when you see percent, and even just think about this in terms of like interest and money, it's going to be an exponential function because you would model this with an exponential growth function. Okay, this would look something like this. So we mentioned earlier it's some common multiplier. In this case, the common multiplier would be 1.05, 1 plus that rate. So this is obviously exponential. Choice 2, a population of bacteria that doubles. Keyword here, doubles. Doubles means times 2. We've seen that on a few questions in this exam. Times 2 obviously is not going to be constant. So if you're multiplying by 2, you're going to start off growing slowly, but eventually you're going to increase exponentially, which is an exponential function, not linear. Think again about like 2, 4, 8, 16, 32, 64, 128. Those numbers get pretty large pretty quickly. Choice 3, cell phone company or cell phone service that charges a base amount plus 20 cents per minute. So if you were modeling this, 20 cents per minute, let's just call it X number of minutes, plus some base charge, this function will look like this. So you have some initial value, some base amount, it's kind of like our y-intercept, and 20 cents per minute. The rate of change is going to be a constant value of 20 cents or 0.20. So because it has a constant rate of change, choice 3 would be linear. Choice 3 would be our correct answer. I'm just going to circle that a little bit more nicely. And as always, let's just go through the choice to see how 4 worked out. Concentration of medicine that decays by a factor of 1/3. Same thing with the growth function in choice 1. If you know or if you can recognize the word decay, that should signal exponential right away. And it even says a factor of 1/3. So in other words, whatever concentration you have, it's multiplying by 1/3 every hour. So again, constant of multiplication or common multiplier, exponential. So choice 1, 2, and 4 all worked out to be exponential. The only one with a constant rate of change is choice 3, which is why it is linear. Okay, thank you for watching, and hopefully you learned something here.